In this video, we're going to talk about continuity and how it relates to the derivative. A big important part to understanding a derivative and understanding the rules that apply to it is understanding when the derivative can exist and when it cannot exist. So to do this, we have to understand that differentiability implies continuity. If a function is differentiable, then it's continuous. However, just because it's continuous does not mean it's differentiable. An example of this is the absolute value function. So the absolute value function is continuous everywhere. However, it's not differentiable at x equals 0 because of the corner. So Theorem 2 states that if a and b are any 2 points in an interval on which f is differentiable, then f prime takes on every value between f prime of a and f prime of b. So again, let's go over that one more time. If a and b are just endpoints, and f is differentiable, that means you can take the derivative of f, then f prime takes on every value between f prime of a and f prime of b. Example 5. If g of x is equal to 1 when x is greater than or equal to 0, and negative 1 when x is less than 0, is g of x the derivative of any function? So let's go ahead and actually graph this really quick. Alright, so this is my graph. And we can see that the derivative is not continuous. So right away, we know that g of x is not the derivative of any function because the derivative has to be continuous. So now we're going to use the intermediate value theorem to show that. So we're going to let a and b be 2 points in g of x where a is less than 0 and b is greater than 0. Then g of a is equal to negative 1 and g of b is equal to 1. However, we've stated that g of x can never, ever have an output between negative 1 and 1. This shows that it's discontinuous. So by the intermediate value theorem, g cannot be the derivative of any function. So notice that right here, you cannot have these values. And because of that, we know it's not continuous because of the intermediate value theorem.